Thank you, Marikera. Thank you, everyone, for coming. So I'm Constantinides. I'm a senior research scientist at Science Center of Excellence in Cyprus. And today I'll talk about responsible AI ethics and extended reality. Does this picture... it's not moving. Why? Does this picture look familiar to you? Well, what it shows some people wearing glasses and an AI that is embedded in these XR intelligent systems. And likely this could be the future of our education. So what I will argue today is that we're entering a world where XR and AI won't just teach us. They will shape how we learn. So education no longer fits the whiteboard. It's immersive, it's embodied, it's interactive, and increasingly powered by AI. And that's what... Sorry, they're not moving the slides here. Sorry. Well, and that's what we're trying to do as part of the European-funded project XR4AD. And our goal is to design, to create, and to maintain a sustainable, on-demand education platform. So here is an example of our project. And here what we're envisioning from the traditional classroom content to creating immersive experiences. So educators and students can create everyday learning materials through voices, images, videos, and panoramas. And then AI enhances these learning materials and turns them into immersive XR classes. And what is the result? The result is avatar, virtual tutors, and rich 3D learning environments that students can explore. And let me show you an example. Here is an example of an intelligent, augmented reality avatar that delivers a presentation.
In this part of the presentation, we will discuss the applications of computer graphics, display devices, the random and raster scan system, graphics input devices, and graphics software and standards. Computer graphics is the process of generating, manipulating, storing, and displaying graphics objects such as pictures, charts, graphs, and diagrams. It is an effective way to present information visually instead of using simple text. Computer graphics allows us to express data in pictorial form, presenting objects as a collection of discrete picture elements known as pixels. In computer graphics, the pixel, also known as picture element or PEL, is the smallest screen element. It is the basic unit that we use to control and represent graphics on the screen.
So just to give you a flavor of what is the present, but what would be the future when new devices are entering the market? What if students wear these kind of devices in classrooms? What happens when they wear them in classrooms, and what happens to the teaching more broadly? When agents handle students' personal data? Or how about the loss of touch, of the human touch that we have in traditional classrooms? How about the reliability of sources? Can we really trust them? Can we really trust the current practices of how we integrate AI into XR systems when it comes to education? But let me step back. First, I'll give you a bit of definition of what I mean by building these systems in an ethical way. And here I'll draw a bit from the literature on AI ethics. One of the definitions that I like to use, it comes from the Turing Institute, where it defines it as a set of values and principles and techniques that employ widely accepted standards of how we design, we deploy, and use AI systems. And that's why we've seen many efforts in the literature trying to map the space of what it means to build AI systems in a responsible way. And this is one of the very first attempts from Harvard folks that tried to build a taxonomy, a principled artificial intelligence, how we put ethics in terms of privacy, accountability, explainability, sustainability, and so on. And many other companies follow suit. They published their guidelines, their principles, what it means to be responsible. But what I will do today, I'll give you a practical framework of how one can embed ethics in their day-to-day jobs, whether they're building XR for education, XR for manufacturing, or any other solution that requires XR and integration of AI. So if we look at the state of the art, that's how it looks like. It's a checklist, ticking boxes. And here's two examples, one from a fairness checklist and another one from an AI auditing checklist from the European Data Protection Board. And they look like this. How many of you in the audience are developers? Great. So as part of your job, you have to scrutinize the resulting system vision for potential fairness-related harms to stakeholders groups considering, and the list goes on. Do you think that would be useful? Would it be usable? Well, what I argue is that checklists are idea killers. They force us to enter a loop, the loop that we break any creativity to think about potential harms or risks or any other ethical considerations that our systems might have. And that's why we developed 22 responsible AI guidelines, and we embedded them in a tool that is more usable, especially for people who develop these very technologies. And these guidelines, this is a big table that I'll try to break it down, consists of 22 responsible AI guidelines that are cross-referenced across ISO standards, as well as the UAI Act. How did we develop these guidelines? We took a co-design approach where we involved different stakeholders, from developers, researchers, standardization, and legal experts. So we followed a four-step methodology. Initially, we looked at the previous literature to identify best practices of what it means to build and integrate AI in our systems in an ethical way. In the second step, we curated and summarized a list of techniques that we identified in this corpus of data, and we compiled an initial set of techniques that we then, in the third step, we evaluated in a participatory design approach through using interviews and actually asking people who are going to use these guidelines, developers, researchers, designers, managers, and the likes, to actually use them and cross-reference them with regulation. And then finally, we further iterated on the feedback in the fourth step that we obtained from these, through these co-design sessions to finalize the catalog. And let's look at an example. A guideline will ask you to identify potential harms of your system that you're developing, and then it asks you to develop strategies to mitigate any identified harms or risks for each intended use. Here, the keyword is the intended use of the AI that we put in our XR system. So let's contextualize this in our space of XR. How can one apply such a guideline? Let me take you back to ancient Greece. Imagine you're having students interacting with a VR that reconstructs ancient Athens. And then there is an AI module embedded in this VR system, a guide that guides the students to ask questions. And then the AI agent replies that women in ancient Athens could vote. Well, this is completely false, but it might feel true inside this beautifully rendered and immersive environment. So a potential harm here if I were to fill in this guideline, would be that the misinformation becomes immersive truth. How can we mitigate that? We can apply some fact-checking on the information that goes out from the AI agent, or we can add a source of explanation on the answers that the AI responds to the user. Let's take another common example in XR education. A student trying to learn in VR a difficult math problem. So the AI tutor, wanting to be helpful, it might instantly overlay the full answer to the student. So what is a harm here? The student doesn't learn to think on their own. They get the answer immediately. So a mitigation here could be that to introduce gradually hints to the user, the student, instead of giving the full answer. Or have some sort of explanation why the agent intervened and provided the whole answer. So as you can see, these 22 guidelines were developed to be intentionally general and straightforward, that they can be applied to any AI problem or project that you're developing and you're trying to integrate in your solutions. But also, they can be contextualized within different roles and projects. And here's how the system works. We developed a card-based visualization where we embedded these 22 guidelines, and then the system asks you to read the guideline and then to reflect how one would have done it or how one has done it. And in this way, we break out the checklist culture, meaning we don't have to tick boxes. I'm not arguing that checklists are not good. They're good for regulation, perhaps as a final step, as a final check in the process of delivering a project. But such approach of having this different way of thinking about ethical issues is better in the early stages of the design and development of an AI system. We put this system into test, and we compared it against checklists. And we found that it was more highly usable than checklist. But more importantly, it was of lower cognitive load. If we recall what current checklists, for example, asks you with vague language and terminology and complicated sentences with nested and structured complex items, this approach is a more simplified and more applicable, especially for developers. Additionally, when we did our tests, we found that these guidelines and our tool enabled people to self-learn about ethical aspects. But it was a reminder that the way we built them, they aligned with their current role as well as with the current regulation. So, if you have 30 seconds, take a screenshot of table 1 from this paper. Great. Now, if you have 1 minute, go through the responsible AI guidelines and the table that you just obtained to familiarize yourself with the key principles and some of the recommendations. If you have 30 minutes, you can individually complete them based on your project. And if you have 60 minutes, you can host a workshop with your team to discuss the completed cards. So, what I provided today is a sort of methodology to build better AI-driven XR systems that we can engage all stakeholders in the process of designing, developing, and deploying AI systems. But also, this approach, we're not treating ethics as the final step in our projects. We embed ethics early on from the design process to contribute at all stages and all phases of the whole life cycle. And finally, and most importantly, we're going to avoid post hoc fixes. Instead of having to redevelop or to have shut down different services because you didn't comply with regulation or you didn't do the right thing, the moral thing, while you're developing your application, having such a structured way of building it in an ethical and responsible way early on from the design phase, it will lead to more robust systems. And to conclude my talk, I would also invite you to come and see us in our booth 501, which is the project of extended reality for education. And there is also a talk later on in the main stage from Professor Fotis Liarokabis at 3:30. So if you're around and you want to know more about the XR4AD project, please stop by. And with that, thank you.
Thank you. Thank you very much. So I don't know if from the public there is any question. We still have some minutes for that. I will come in the front, so maybe my voice doesn't come from.
I try to be responsible and on time.
Super
and
ethical.
leave some time
Very
for
ethical.
questions.
So is there any questions? Okay, I'll go first. So in the process of designing ethically, sometimes there is something that cannot be understood before implementing and deployed. Mm-hmm. Do you already have a framework from, let's say, the implementation ethics?
That's a great question. So 100%, we cannot foresee all the ethical issues, and it needs to be a sort of iterative process. And having these guidelines be applied and integrated early on in the design process. So even if we identify some aspects later on, we can fill in these cards at different stages, right? And then we can compare our previous ways of, let's say, reflecting on certain ethical issues. Or if I identify something later, then I can reflect what I could have done differently in a previous phase of my project. So bottom line is that these guidelines are not for the end. It's just an iterative process that can be filled in all stages.
Thank you.
I think there are a couple of more.
So I'll start from here.
Thank you for a nice presentation. I have a question related to, have you tested your guidelines in combination with students meeting companies or startups?
Can you please repeat?
Have you been testing the guidelines and also the card game together with students and companies? I think about how to use it when you are a startup.
With startup, no. We've done a lot of testing it in different settings and different environments. With students and educators, we've run other type of workshops in a similar manner, co-design and participatory design fashion. We have some results for this we'll present later in the main stage. But if you're interested, why don't we collaborate and we do it together? Okay. Thank you.
That is why we are doing this event too. So I saw the... Thanks.
Hello. Thanks a lot for this very interesting presentation. I'm coming from the heritage field. And when you showed us the Parthenon, I was wondering, how do you address research gaps in your content through AI?
What do you mean by research gaps?
Things that we're not sure of about the past, for example, that we don't know what happened or how exactly something is.
I think it relates a bit to the first question from Marie Chiara. This process, in a sense, there is no right and wrong answer whatever content you fill in these cards, right? So even if there are things that you identify later, you can still iterate, and then it also could be seen as a way to surface these research gaps. Imagine a big team of people, and each one fills in and completes this process individually. Then when you consolidate and you merge all together, that's a point of discussion. So you have material for discussing and identifying these research gaps. So you can use it as a tool, in a sense, to identify the research gaps.
Thank you very much.